I'm planning to give the second test 2 weeks from today, 24th March. I'll give you a list of things to study, but it'll be up to chapter 9, okay? And I'll focus a little bit more after test 1. That's chapter 5, okay, after chapter 5, but they're all included, 2 through 9, okay? Focus is on 6, 7, 8, and 9. Okay, so let's continue with while loops. These are very important. Just loops in general. For loops, while loops are both important. No, sorry, this is chapter 9. They're also called repetition structures. And we'll start with the while loop. These are very simple and very useful. So let me go through 3 or 4 slides and an example, and then we'll see what's happening here. You got to initialize a variable or two, then write a while loop with a condition in it, and at the end of the loop, either an increment of the variable which was initialized, and the only way to understand it fully is with an example. So this is what the flowchart looks like. Boolean expression, if it's true, keep doing these statements over and over as long as this statement is true. This condition is true. When it becomes false, you'll continue with the rest of the program. Please note this test is made after each time you do all the statements, okay? So this is what pseudocode looks like, initialization, otherwise the while loop may not start. While Boolean condition do any number of statements and increment. So let's get to the example. Suppose you want to print all the numbers 1 to 3, that's all. Does this make sense? This is a pseudocode. Initialize a counter, we call it count, to 1. And as long as it's less than equal to 3, print the count. And do you think we should increment the count before the while loop ends? So count will now be 2, right? And you make this test again. It's still true. So go print 2, make the count 3. Please note the structure of this statement. This increments count by 1. Okay? Sometimes you have to decrement the value depending on the type of loop. Okay, so that's the flowchart. Initialization, count is set to 1. As long as it's less than equal to 3, print the count, increment it, repeat over and over till this becomes false, and then you stop. Okay? So this is very important also. This is called a trace, and please note count was set to 1 initially, and at that time this was true, so we printed count, which was 1. Increment count, so count became 2. This condition is still true, print 2, and so on. So are there any questions on this? Okay. When does the loop stop? When it's a 4, right? When count is 4, this condition is false for the first time, so you'll continue the pseudocode after the end while. Okay? So this is for the trace. This is a far more accurate trace than the previous one. So in the flowchart, we've labeled these A, B, C, D, etc., all the boxes. And after you're done with A, what will be the value of count? So this is the box that you're done with. The value of all the variables goes here, including the value of the expression, this expression, count less than equal to 3. After you're done with B, That's true, isn't it? Because count is still a 1. Okay, so you go and do C, produce the output 1, go to D, because after C you have to do D. Count is now 2, so after you're done with D, count is 2. And then you go back to B, right? So the condition is still true. This is simply the iteration number, how many times you're going through this loop. Okay, so we produce 2 also at print count here, and count now becomes 3. Because this count less than equal to 3, it's still true, right? 3 is less than equal to 3. So you come here, print 3, increment count to 4, and for the first time this condition is false, so you stop at box E. Any questions on that? Yes?
On the, in the count column,
Count
we
column.
only show 1, 2, 3, and 4 in those single blocks, but count actually stays that value all the way through. Is that the convention, is just to show it the one time?
No, this is a single variable in the computer, single location. So it in fact changes the value.
But we are looking at the value of the variable at that point, correct?
After we are done with that box, yes.
Okay, but what I'm saying is in the count column, we
Yes.
only show its value the one time. Is that the convention in doing a trace table? Okay.
We are showing it multiple times, right? As it changes. I don't understand your question fully.
Okay, when
You
count
only-
becomes 1,
Yes.
instead of showing it in the next row as 1.
Oh, here, okay, I see what you mean. B and C.
just
It's understood that it's the
clutter.
same.
Okay.
Okay.
All right.
But if you want, you can of course show it another time in both of these positions and so on. Okay?
Okay. Thank you.
Okay, welcome. I mean, there's no point repeating every single value for every single variable or expression because it's the same. Okay?
Okay.
Thank you. Okay, so this is finally the Python program. Count is set to 1. Please note while. It's not an if. While means repeat whatever is underneath over and over again. As long as this condition is true. And then there's a colon to indicate the end of the while, and everything that's indented is part of the while. Okay? So you print count, increment it, go back and make a test again. So this is the output. Any questions on that? Okay.
Quick question.
Yes.
So in Python, pardon me, in Python, there's no end while
There is
or
no
anything
end
like
while.
that. It just,
The indentation
It just
takes
dumps
care
out.
of it. Yes.
okay.
The next statement would be written in line with while, and that will be done when the loop stops. Okay. So this time we're going to print 1 to 4 square, 1 square, 2 square, 3 square, and 4 square. Very simple problem. Show the trace and the output. So we start with the pseudocode or the flowchart, and I hope this is clear. Num is set to 1, and as long as less than equal to 4, you're going to repeat all this till end while. Calculate the square of the current value of num, print it, change num to the next value, and keep repeating. In pseudocode, indentation is not important, so end while is important. Okay? And the flowchart is exactly the same. Num is set to 1, as long as it's less than equal to 4. Figure out the square, you do the right side first of course, print it, increment num. If this is still true, keep going. So this statement is very important. Without that, you are trapped in an infinite loop. Keeps doing the same thing over and over again. So in which case, if we left this out, it will print 1, 1, 1, 1, calculate the square of 1 over and over. Okay? So that's a bug in the program. The Python is very simple. Num is set to 1, without which this statement would not make sense, right? Num less than equal to 4. Because you're testing a variable, it has to be set to something. That's why we have initialization. Calculate the square, print it, change to the next number, and keep going, and this is the output. Okay? And this is the complete trace. I don't think I'm going to go over every single line of this, but after box A, num is set to 1. So go back to the flowchart because that's the place where we have these labels. At box B, we evaluate this condition. That should be true, right here. Calculate the square, produce the output. Increment num, and then go back and make the test again. So any questions on that? And like you said, you don't have to show the same value over and over if it's the same. This is clearer anyway, right? Okay. Now this is where the program is similar to homework 4. Let's say we have the sample data for a student, one student, who has taken a few tests, 90 in the first test, 80 in the second, 75, 85 in the next two, and this is a sentinel, or an indicator which says that there are no more grades. We could have 5 grades, 3 grades, 1, at least 1, okay, otherwise the program doesn't work. And we are supposed to calculate the average of all these. So that's the complete flowchart. Before we get the score, or anyway, before the loop, do you think we should initialize these two? Total sum is 0. That is the sum of all the grades. Otherwise, this wouldn't make sense. Sum equals sum plus score. And counter equals 0 because this wouldn't make sense. Calculating the average needs a counter, how many grades there are. So initialize both to 0. But please note this based on the score. We read the score, and if it's not 0, go through these steps over and over. And if it hits 0, then you calculate the average and print it out. Okay? So these labels are again for the trace. Well, let's go to the pseudocode and Python, and then we'll worry about details. So counter is set to 0, sum is 0. Get the first score. If it's not 0, add it to sum and change the counter by, you could interchange these two statements, makes no difference. But this is extremely important. Don't you think we need to read the next score inside the loop? There is no way to come back to this. Okay? If you leave that out, and we read the first score, this will be again an infinite loop, keep going forever. Okay? So you have to be very careful when doing the program or the pseudocode or the flowchart. So when the loop stops at this point, calculate the average and print it out. So finally the Python program and the interaction. Counter is set to 0. Sum can be, well, it's an integer we are assuming, but suppose somebody has 87.5 as a grade. We want to take that into account. So that's why we have a float value here. Read the score, convert to an integer. Okay, we could have used float for more general data. As long as it's not 0, do both of these and read the next score. So first score entered is 90, so it's not 0. Sum is now 90. Read the next score, so it produces this line. We type in 80, so that's not 0 either. So counter is now 2, sum is now 170, right? So far, it's a running sum, running total. And finally, when we enter 0, whatever the sum is, divided by 4 to get the average. 4 because after 4 grades we have a 0. If after 3 we had a 0, then we would be dividing by 3. Value of counter will be 3, right? So any questions on this? Please note the colon here after the while, and these 3 statements are inside. The blank statements are just for readability. It's a good idea to do that. Make the program as easy to understand for others. Okay, this is a complete trace. I'm not going to go through all of it, but perhaps the first 5 lines. At box A, initialization, counter is 0, next statement sum is 0, and finally third statement we read the first code 90. So this condition is true, and therefore there's no output at that point. There's no print statement inside the loop, right? So we read the next code. Was that over here? Okay. I think we may have missed a step. Anyway, D, E, F, G repeats over and over, right? So one of them is read the score again, and that's the 80. I think this is correct. Just have to go through it very carefully and compare it to the flowchart. Okay. Finally, you see that this sum is 330 because you've added all these grades before entering the 0. Soon as you enter 0, the while loop condition becomes false, right? And you calculate the average and print it out. This output could be a separate box, it doesn't matter. But again, the basic idea behind a trace is you have to write all the variables at the top. Sometimes you can omit a few, and you write all the conditions of all the while loops. And again, if you want to compress the table, you can leave some of these columns out. Okay? So please look at that very carefully and understand while loops fully. For loops are similar, except they put in the initialization, the condition, and the increment in just one step. Okay? And remind me to do the visual logic version of both of these, because that's not in any of the examples we've done so far. Bunch of statements and for to indicate that. So this is the pseudocode. Or in a flowchart, it's more like this. You write a for, and all of these things, all the statements inside the loop, and the for loop ends there, so it's implied that it does it over and over again till this condition is false, and then you exit. So we'll take some examples of that. I'll run some code samples of Python also and show you which are important. So in some languages you use for loops strictly to go through the loop a fixed number of times. If you have n set to 10 or something and you use n less than equal to 10, then this will go through 10 times, assuming initialization is 1 to n. We'll come to some examples, so don't worry about it. So a very simple example where you have to print the count from 1 to 3 is this. Count is initialized to 1 as long as it's less than equal to 3. Increment count at the end of the for loop. So print count equal to 1. Then this is done at the end of this loop here. Count is now 2, and so on. So this is pretty obvious. And we write an exit here instead of false or true. So in pseudocode we would write like this. And this again the same exact trace that we had earlier. But it doesn't show the statement. If I label these A, B, C, then it might be a little more detailed. But let's get to the Python program. Please note, and I don't know why they did it like this, for count in range 1, 4 with parentheses, colon, makes the loop go only 3 times. It does not touch the last value for some reason, okay? So this expands into 1, 2, 3 basically, okay? So this is the output. And we'll come across 1 or 2 more examples in a few minutes. Again, now we are using for loops to print out the squares between 1 and 4, 4 included. So pseudocode, you write this: for initialization, num less than equal to 4, etc. Calculate the square and print it, and go to the next value, okay? And this is the flowchart. And finally, please note the 5 here. If you want to go through 4 times, you got to have a value 1 larger than that. Okay, so this is the output. This is an important flowchart also. Suppose you want to find the product of all the numbers between 1 and 30, odd numbers. So 1 multiplied by 3, multiplied by 5, multiplied by 7, and so on. You can have an increment of 2 over here. But why should we initialize product to 1? Because if you multiply 1 with num, where num is a 1 or whatever, that gives you a positive number, and then you store it back in product and repeat. So when num is 3 and product is 1, 1 times 3 is 3, store 3 in product, go back, num is now 5, right? So 3 times 5, 15, store it back in product, keep repeating. When you're finally done multiplying 1, 2, 3 up to 29, num becomes 31, so you don't do this loop anymore, print the product and stop. Okay, so let me just complete the next couple of slides and we can discuss it in more detail. This is exactly the same as the previous slide, this flowchart. So are there any questions on it? Please note we are printing the product only after this entire loop is done and just once. If you wanted to print it every single time it changes, you would print it here. So once again, this program is important because you need to initialize product to 1. Please note that you can include the increment right here as a 2 here. By the way, all of these things can be variables as long as they're initialized, okay? And that's the final output. Okay, I'll come back to the code samples. I need to do some structured flowcharts also and visual logic also. So there's a little bit more to do today. Sentinels, again, you could have sentinels of various types. While loop can have example, a Boolean variable. So more is set to true, right? While more is true, you want to repeat all this. And while here. If you enter a 1 or a 2, this loop should keep going. Okay? When you enter a number 3, the loop should stop. So that's why it's saying please enter an option from 1 to 3. If you get the value of option and it's equal to 1, you do a print statement here. Otherwise, if option is 2, you print that you selected 2. Finally, if you selected 3, it will print goodbye and set more to false only in this place. Therefore, will the loop stop? When you come back up here and test more, it's no longer true, right? So the loop will stop. Okay, people use this Many times, for example, you put in the wrong data, so you need to keep looping till the user puts in the correct data, right? Okay. This left as an exercise. You can easily convert that into Python. And you could replace more, the variable more, with a Boolean expression based on the number, right? Like we saw earlier, while count is less than equal to 4, for example. Count less than equal to 4 compares two values, so it's a Boolean expression. I guess this is the Python version of it. More is set to true. Please note Python requires T to be capital for true and false. False is capital F. And then you read in an integer 1 to 3. If it is equal to 1, you print this. If it's otherwise elif, it's equal to 2, you print this. Else, you print goodbye and set more to false. So this part of this else, both of these statements. So when you come back up here, more is now false, so you'll stop if you had entered 3. So this type of structure is used very often, like I said, for verifying if the input is correct. And that's the interaction. It prints out enter 1 to 3. If you enter 2, keeps going. If you enter 1, keeps going. Finally, if you enter 3, prints goodbye and the loop stops. Now, you could, instead of more, you could use something like this. While option is not equal to 3, keep going. Okay? But that wasn't done in these slides. Okay, do while is used, we don't have this structure in Python. It's used in some languages where you have the do here and the while on the other end. Sometimes it's called an until. So you do statement 1, then do statement 2, then you make the test and come back to the top as long as the condition is true. If you use until, it would be the other way around. So we are not going to discuss it in more detail except just to make the pseudocode complete. So this is called a do while instead of a while do. That's all. And I am not going to test you on this either because there are not many examples. So the flowchart would be like this. You always do these statements first, then you make this test. And as long as this condition is true, keep repeating. Finally, when this condition becomes false, you would come to the next step. Okay, so once again, we're discarding the do while. You could do it with both a while or a do while. Read the value first, and if you've not entered a positive value, you want to keep going till you enter a 0 or a +5 or something. So negative set to true, and then you check if it's less than 0. If it is, you got to read the value again, right? Because they made a mistake in entering another negative value. Otherwise, they have entered a positive value, so you set negative to false, and therefore the loop will stop. Okay? Because that will be tested after the end while. Do while would be very similar, except the test is made here, and this pseudocode, please note it's not Python. So next set to true. If I enter a positive value, I set negative to false, so I don't continue the loop anymore. And if it is not greater than or equal to 0, then we've ended the if, so negative is still true. So we're going to repeat. Since Python does not have a do while, we do it always with while at the top here. So negative is true, while this is true, read the next value. If it is positive, then set negative to false, so the loop stops. So if you enter -4, -10, -5, and then finally, which is not shown here, if you enter a +7 or something, then the loop will stop, right? I don't know why that wasn't shown, because it would prompt you for please enter a positive value, colon, I type in a 7, and the loop stops. Okay, infinite loops, for example, this in pseudocode, while true. Some people write that, and occasionally you may need it, but I mean, most of the time you don't want infinite loops in your user programs. You may have it in an operating system type of program. Anyway, so will this loop ever stop? No, it'll keep printing hello over and over again, right? Because this condition is always true. Let me go to the samples right away, and I'll do the flowcharts first, because they're pretty easy to understand also, visual logic. Okay. Does anyone see visual logic anywhere?
Second row, second one over.
Here it is. Yeah, thank you. Okay, first an example with the while loop, and it shows you a loop here, while true, repeat, and now you got to fill in the expression. But suppose before that I read in a value for a variable, num, let's say. I'm going to repeat this loop while num is less than equal to 10. Okay? And then print something out, output. And I want to print out, I made one mistake already. If you input a fixed number, okay, this is what I wanted to do. Print the squares from 1 to num, all the squares. So this expression is wrong. I'll come back to that. So output will be, let's say we have a counter, count to the power 2. Okay? And therefore this should be not num less than equal to 10, but count less than equal to num, right? Now, because we have count here, do you think we should initialize count before we enter the loop? Otherwise we may not. Normally in a computer, the value of a variable is undefined until you initialize it. So it may or may not begin the loop. So you got to initialize count either here or after input in an assignment statement. Count 1. Okay. Now, of course, since a while loop, do you think I should increment count over here? Assignment statement. Count should be count plus 1. Now the whole thing makes sense. Okay. But just to test it and make sure there are no errors in it, let's begin and run it. Type in a value for now. Just to make this clearer, let's make all input output console mode. So input console, output console. Okay. Go back and run it. Now we can see a little bit better what's happening. Suppose I put in 9, for example. Now it actually printed 1 square, 2 square, 3 square, 16, 25, etc. But we can't read it properly. So the only error is in this output. We got to fix that. Close this and edit this. At this point, I think all you have to do is hit enter to make it go to the next line. Okay. Suppose I enter 9. It goes through the loop 1 to 9, right? Now if I change this less than num, it'll stop at 64, will it not? Okay, so you have to be very careful in how you specify the condition and the initialization. Do you have any questions on any of this? Okay, now for the same problem, I'm going to replace this with a for loop. So I don't need this, delete it. And instead of this, it's a bit late to put in a for loop here, so I'll have to restart. I don't need this either, but I do need this. So let me redo this, starting over. Okay. And you'll see for loops are a little bit easier in this case. First, we got to read in num, right? Okay. And please note this different type of box here. You got to put in all these. Variable name for I, let's say. I is used very often, although it may not be a good choice. Final value should be less than or equal to num. So you can't really write a Boolean expression. This is different from pseudocode. Okay? And step size is 1. So that's the for loop. I goes from 1 to num. If I enter 9, I will go through all of those. It's different from Python also. So output should be I square. Console mode. Okay, and this also I forgot, should be console mode. Okay. Now if I run this, it's doing this for loop 9 times. For I equal to 1, produce I square, etc. Num does not change, right? So this is an example of a for loop. Any questions? Okay. You'll have to try these out, and especially for homework 4, you already have to do it in both Visual Logic, okay, and Python. So that will give you enough practice, I hope. Okay, let's go to the code samples and then the structured flowcharts, then I'll be done. 120-1 code samples. Okay. Out of all these, please note the important ones are, if you want to note it down somewhere, and I'll run some of these, but perhaps I'll forget 1 or 2. So the for loop example is important. Okay. We'll come to nested loops later in the next chapter. So These three are for the next chapter: multiply, nested loops, nested for, nested loops. And while loops are important for this, so these two are important. So let's see if there's any other I can think of. Average, yeah. Average 1 and 2. I don't know if there's a difference there, but let's run this one. I see it's open it with 2.7.8. You have loaded through 3.0, but I don't think there's any difference. So once again, this finds the average of grades of n students. So it's going to count the number of students so it can figure out the average here. Okay. Why do we have this if statement here? Suppose we enter no grades at all. Some will be 0, none will be 0. We don't want to divide by 0. Okay. So suppose I have 4 students with grades 80, 90. Oh, this is producing sort of a trace. We are in Python older version, so it's printing out the parentheses, but it's printing the current sum and the current num. Okay, 80 and 1, 170 and 2, because it's just added 90 and 80, and the number of students is 2. Finally, I'm going to enter a 0. No, this is, suppose somebody has 0, that should be included, right? So we have to enter a negative number, -5, for example. It's printing out number of students is 3, sum is 270, and the average is 90. Okay. Now, if you run it in 3.0 or above, it'll be a little bit cleaner. Okay. Let me see if I can run the next one that way. Average 2, was it? Yes, average 2. So I have to start the correct version of Python. And this time I'll load average 2 in a new window. Open from the Z drive, the Y drive, Spring courses, code samples, average 2. This time it's the same example as in the slides, so we are entering a bunch of grades and we have no tests, so this possibly an error, right? Suppose I enter no grades at all. I'll show you the error in a minute. So for one student we are entering several grades, okay? And I have only 3 or 4 more to run. So suppose the student is made in 18 one, 19 the second. It's producing a running total, and 16 the third. And then I'm going to put a 0 in to stop the loop, and that's the average without the formatting. Okay. Now suppose I run the same program with no grades at all entered. So I'm going to enter a 0 right away, and I'm going to run into a severe error because it's telling me what the error is. In this statement, we are trying a division by 0 because sum is 0 and counter is 0 at that point. We've started the loop already by entering a 0. Okay. So to prevent that error from occurring, I should put an if statement here. If counter is less than 1, then that's an error, right? Just like I had in the previous case. Okay, let's see if there's 1 or 2 more. The for loop example, the for loop is very important. So file, open. from the Y drive. For loop. I'm going to print the square of a number formatted with this statement. Why do I have limit plus 1 here? Limit is, let's say, 10. I want to print 1 to 10 square. So since the for loop stops 1 earlier in Python, I should put limit plus 1 over here. Okay? So suppose I enter 10. Oh, this is the bug which we keep running into. We did not accept 10. Okay. I guess the format must have a $sign in it. Yeah, this dollar should be removed. So please note, because limit plus 1 is 11, this loop is done 10 times. Okay. The while loops, and then I'll go to the flowchart, structured flowcharts. Give me another 10 minutes, I'll be done. File, open. So this is also printing the squares of numbers. Please note you got initialization, 2 of them. Num should be initialized too because this has both variables. And increment. Enter a positive number, let's say 10. And it prints this as output, both I and the square of I. And finally, let me run that last one. Oh, sorry, it's the other one. Samples, the while2. And this is just limit. It's a while loop, it's not a for loop, so it doesn't create additional, I mean, you don't need plus 1 for that. Okay. And unfortunately, we still have the $sign, which can be removed. Anyway, let's run it quickly. If I enter 10, it will go 1 to 10. And that's the output. Okay. So I'm done with most of this, except this handout 1, which I gave you, is still important. So let's see if I can get this going. What's it called? I've forgotten.
My projector.
Projector?
Start.
Document camera, right? Measurement, okay. I don't know if I can enlarge it. This way to enlarge it, but let me try for 1 minute. No. Zoom in. Yeah, here we go. Zoom. focus. It's too complicated sometimes. Can you still read it? All of you have this handout. I think we can read it. So this is a structured flowchart as opposed to the standard one. And I like these a little bit better, so you can expect one on test 2 or test 3. Okay? Start. These boxes are numbered. Don't have to number them. Read in N1, N2, N3. So you're going to print the largest of the 3 numbers. Now this is an if statement. If N1 is greater than N2, all of this to the left is the yes part or the true part. All of this to the right of this line is the false part. So if this is also true, you're going to print N1 as the largest. If not, N3 and so on. So please study this. It's not difficult at all. And try and write the Python version of it, which is also very easy. I think I've already got this on code samples. Okay. Now, since we've studied Boolean expressions, there's a simplified form of that. Read N1, N2, N3. If both these conditions are true, that is N1 is greater than N2 and it's greater than N3, just print it out here, N1. Otherwise, we know these are comments in the asterisk slash and slash asterisk. If this is true, print N2, otherwise print N1, N3, I'm sorry. Okay, so these are very simple flowcharts with no loops. Now loops are written this also without a loop, and it pertains to the 2 forms, 2 versions of this. I'll show you both. Okay. Calculate the pay of 1 employee only. So read the rate of pay and hours worked. There are 2 variables here, but this is pure English, so it's a little bit harder to read and understand. Has the employee worked more than 40 hours? If yes, give them overtime pay, right? Otherwise, no overtime pay. In both cases, when you come out and meet here, print net pay. Net pay is what you're calculating here or here. So this flowchart is more general, and you can be more specific. This is version 2 of the same thing. Read rate, comma, hours. If hours exceeds 40, calculate the net pay using 1.5 times the rate for the extra hours. This is in the book, by the way. The solution is in flowchart form and pseudocode, I believe, in chapter 6. Whenever we discussed if statements, okay? And you're going to use this idea for homework 4. So print the net pay at the rate for so many hours. That will give you the pay. So these flowcharts were without loops, and I'll go through maybe this page for flowcharts with loops. Okay. If you're supposed to compare investments, that's the heading of the flowchart, and you put $100 in 2 separate accounts. One is a simple interest account, which pays you 7% per year on the original deposit. Whereas the second one is a compound interest account, which pays you 5% on last year's balance. Okay? So that's why we have comp here. Go through a for loop 10 times, and you have values for simple and comp. Then compare which is better. Suppose simple is greater than comp, you'll print simple is better. If both happen to be equal, you'll print either one and say both are identical. Otherwise, you'll print compound is better. Okay, so this is worth doing in Python also. let's see, which one do we have here? Yeah, this is the factorial program. If you have to calculate the factorial of 10 in this example, n fact is 1, and you're going to print out all the factorials from 1 to 10, numbers 1 to 10. So this statement is the critical one. For n going from 1 to 10, as you generate a new n, multiply the old value of n fact and put it back in n fact. So try and trace this, see what it produces, and at the end of this loop you should have 10 factorial. Of course you would have printed 1 factorial, 2 factorial, 3 factorial, and so on. Finally, this last example demonstrates while loops and brings out an important point. If you've got to find how many years it takes to triple your money in an account, then you definitely need a while loop. You don't know ahead of time how many times you'll go through the loop, okay? So you have to use a while loop like this. Years is set to 0. We have $100, let's say, in an account, and while it's less than $300, we've not tripled our money. So this is the compound interest statement. Principal plus times 10%. This could be a variable, but then you'll have to read it in, make the program more general. And years will become years plus 1. So at the end of the loop, you want to print that variable. How many years does it take to triple the money, right? So I can't use a for loop here at all. So while loops are more general. For loops are normally used for a case like this, if you know how many times you want to go through the loop. Anyway, study all of these flowcharts. There are 2 more which I'm not discussing. They're more complex, 2 or 3 more. Now that was just the factorial thing again, but I had a Japanese version of a book long time ago, so. And these 2 are for perfect numbers. They're a bit more complex, so if you can understand it, fine, otherwise don't worry about it. Okay, I'm going to stop here.